Find the equation of the parabola described below. Find the 2 points that define the latus rectum and graph the equation. So we're given that the focus is at -1, 0, and the directrix is the line x equals 1. Before we get into this, I really want to take a look at what the features of the parabola are so that we know how to relate these things to each other. So I'm showing a picture of a parabola with the orientation that I call opens up. And what I want you to notice are these special features. We have the vertex right here, which is the minimum in this case. It's also the place where the graph changes from decreasing to increasing. Then inside the parabola we have the focus. And the focus is a distance of A away from the vertex. In this case, because the parabola is oriented up, the focus is up from the vertex. Then we have the directrix. And the directrix, you can see, is running perpendicular to this line that connects the vertex and the focus. And the directrix is also A away from the vertex. So this distance, this perpendicular distance right here, is A. So this is the equation right here, which gives us a parabola that's oriented up. That's this one here is a parabola that's oriented up. And the squared is on the x, and we have a positive on this side over here of the equation. When we put a negative instead of a positive, so the squared is still on the x, but we have a negative, this is the orientation that is down. And then over here we have some equations where the squared is on the y, and when the squared is on the y, you have a parabola that's oriented either left or right. So when we have a positive, it's to the right, and when we have a negative, it's to the left. One more thing I want to point out to you is that we also have something called the latus rectum. And the latus rectum will be points that are in line with the focus. These are points that are on the parabola, and they create this line segment going through the focus. So because they go through the focus, they're going to share some of the coordinates from the focus. In this particular example, the y-coordinate of the focus will be the same as the y-coordinate on these 2 points. However, if your parabola is oriented, say, to the right, our focus will be here, and our latus rectum points will share the x-coordinate with the focus rather than the y-coordinate with the focus. With all that in mind, let's give this problem a try. For this example, we're given that the focus is at -1, 0, and that the directrix is the line x equals 1. So the first thing I want to do is figure out the orientation of this parabola. So drawing my picture, this is just a sketch of the picture. If I have a focus at -1, 0, that would be here, and the directrix being the line x equals 1, I know that the parabola will be oriented to the left. And that's because the focus is going to be inside the parabola, and the directrix will be running perpendicular to the connection between the focus and the vertex. I also know that the vertex is at 0, 0. And that's because the distance A between the vertex and the focus is the same distance between the vertex and the directrix. So my focus is at -1, 0, and my directrix is the line x equals 1. Halfway in between those two, we have the vertex, which is going to be at 0, 0. So what we know is that we have a parabola that's oriented left that has a vertex at 0, 0. So this helps me know which equation to start from, which equation template. So we're going to start with y minus k squared minus 4a times x minus h. And we know that because the vertex is 0, 0, my h equals 0 and k equals 0. And a is the distance between the vertex and the focus, and that distance is 1. So we're going to be able to substitute these values into the equation template to get y minus 0 squared equals, I left off an equals up here, equals -4 times 1 times x minus 0. That gives me y squared equals -4x. So that's the equation of the parabola with a focus at -1, 0 and a directrix at x equals 1. Let's draw a little bit more detailed picture. So we said we have a vertex at 0, 0, a focus at -1, 0. The directrix is along the line x equals 1. And I want to find the lattice rectum points. The lattice rectum points will help me to draw how wide this parabola is set. So remember that the lattice rectum points, I'm going back up to my sketch for a second. My lattice rectum points are going to fall on the same line with the focus. So with this orientation of being left, it's going to share the x-coordinate with the focus. So the x-coordinate of the focus is -1. So I'll take the equation that I found previously and substitute a -1 and solve for the y. So -4 times -1 is +4. I can square root both sides to get y equals plus and minus 2. So our lattice rectum points are -2, -1, and oops, I've got my coordinates backwards there. -1, -2, and -1, +2. Let me mark those on the picture. -1, 2, and -1, -2. So now I can sketch the graph of the parabola. Oriented left with a focus at -1 and a directrix of x equals 1. Thank you for checking out my videos. Have a great day.